Today we will discuss the isometric projection drawing using solid edge V19 software. At the beginning, make sure you have done sheet setup, A4 size sheet, and switch off the background. And make sure in tools you have alignment indicator and maintainable relationship, both are checked in. Let us discuss the problem number 1. A sphere of diameter 50 mm rests centrally on the top of cube of side 50 mm. Draw the isometric projections of the combination of solids. Let us take the thick line 0.5 mm continuous line, 50 mm length 30 degree, 50 mm 150 degree, 50 minus 150, 50 minus 30 gives you the top face of the cube, 50 mm minus 90 degree, 50 mm minus 90 degree. You take from all the three corners to get the thickness of the cube and join to the respective corners. So this gives you the cube. Now join the opposite corners. The midpoint of this line will be the center of the cube. From there you measure the radius of the sphere. The radius of the sphere will be 25 mm. So 25 mm 90 degree. So before drawing the sphere, you should take the scale for the cube. So select the cube, go for modifying commands, scale, give 0.816 is the isometric scale and reduce to isometric scale. Then use circle. This will be the center point for the circle and diameter will be 50 mm. Take trim command and remove the unwanted, hidden and construction lines. So this will be the solution for example problem number 1. Example problem number 2, a hemisphere of diameter 40 mm is supported coaxially on the vertex of cone of base diameter 60 mm and axis length 50 mm. The flat circular face of the hemisphere is facing upside. Draw the isometric projection of the combination of solids. So let us draw the base of the cone. The cone base is 60 mm. I take construction line, continuous line. So 60 mm 30 degree, 60 150, 60 minus 150 degree, 60 minus 30 degree. Then join the ellipse by midpoint method. Join the corner to opposite midpoints. Join the corner to opposite midpoint. Use arc by center point method. Draw the first arc, keeping this as the radius, and get another arc like this, and the intersection of these two lines will be the center for the third arc, and intersection of these two will be the center for the final arc. So this is the base of the cone. Now you find the center by using this alignment indicator. The axis length is 50 mm. So choose axis line. The center of the cone will be here. You can see the relationship from the corner, or else you can draw a line from this point to this point. The midpoint of this will be the midpoint of this line will be the center. So from the midpoint of this line, we measure axis length 50 mm 90 degree, right? So above this the hemisphere will come. The hemisphere diameter is 40 mm. So radius I will take 20 mm further 90 degree up. Anyhow, I have a ellipse of size 60 mm. I'll choose this redrawn ellipse and I will copy using move command. I'll switch on copy with respect to the center of this cone, and I'll place at the top of this cone. and reduce the size using scale, the scale factor should give the ellipse I wanted is 40, should be in a numerator, and ellipse I already having is 60. So 40 by 60 we have to give as a scale factor. So this is a new ellipse and click on that end point. That is the center point of the ellipse. Then take arc by center point method. From this center, draw a semicircle. This should be a continuous line. And the cone part is the vertex of the cone. The vertex of the cone, see, this is the cone axis, the end point of this. So this is the vertex of the cone. Join a line such a way that the vertex line from vertex to the tangent to the bottom ellipse. Trim the unwanted edges. Trim the unwanted corners, the construction lines. Don't delete the axis of the solid. You can retain the axis of the solid. Anyhow, the vertex is going to be invisible, so we can trim these two also. So this is the combination of solids. We will make this very thick, but axis should be thin line. So 0.13. Take scale, convert to isometric scale. So isometric factor is 0.8164. This is the solution for example problem number 2. Problem number 3, the isometric projection of a rectangular prism 60 by 80 by 20 thick surmounting a tetrahedron of side 45 mm such that the axes of the solids are collinear and at least one edge of the both the solids are parallel to VP. So we have tetrahedron here and a rectangular prism. So let us draw the rectangular prism first. I take 60 mm to right hand side, 60 mm 30 degree, then 80 mm 150 degree, 60 minus 150 and 80 minus 30. So this gives the top surface, the thickness is given 20 mm, so 20 minus 90 degree you can take from all the corners, 20 minus 90 degree and 20 minus 90. So the rectangular slab is completed. Let's move on to the tetrahedron part. So tetrahedron is a solid in which all the sides are of equal length. It's almost like a triangular pyramid, but in the speciality is all the edges of the tetrahedron will be are of same length. So for which we need to draw the orthographics to find the height of the tetrahedron. Let us draw XY line. So this is XY line. Let us construct a triangle of side length 45 mm. 45 mm 0 degree, 45 120, 45 minus 120. Rotate this triangle in such a way that one of its edges comes to the left. Join the corner to opposite midpoint to get the center of the tetrahedron. And trim the unwanted edges. So this will be the top view of the tetrahedron. Now take projection of this solid. This is the top view of the tetrahedron. So make it thick, 0.5 mm. Take projection line till XY line. And this is the center, project till XY line. And this is the corner till XY line. And show the axis from center. We don't know the height of the tetrahedron. Draw a certain length line. Now take an arc by center point method. Take from this corner in which one of its slant edge which is parallel to the vertical plane. So from this, keeping this as a center, radius you take 45 mm, cut an arc. Complete that front view by joining the line. Now this will be the front view of tetrahedron of side 45 mm. Get the distance between command and find the distance between these two corners and the distance between these two. In fact, we are enclosing this solid in a box using distance between command. At the same time, we are getting the dimensions also. And we can measure the height of the tetrahedron also. The height of tetrahedron is wherever the distance between the reference line to the vertex of the tetrahedron. So we can construct the tetrahedron as separate, then we can move that one above the other. Let us construct tetrahedron. I take this 38.97 mm on 30-degree line. So 38.97, 30 degree, then 22.5 on 150 degree, 22.5 on 150 degree, 38.97 minus 150 degree, 45 mm minus 30 degree. If we join these endpoints, we will get the base of the tetrahedron. Now we measure the distance between the center to the one of its edges, 12.99. So I take from this midpoint 12.99 at an angle 30 degree, which is parallel to 30 degree line. From here, we need to measure the height. I take axis. The axis is 36.74, 90 degree. We can join the corners to the apex now. So from here to end point, join to the apex to the end point. Find the midpoint of this rectangular slab, join the midpoint of opposite two lines, move this tetrahedron, move with respect to this center of the base of the triangle and place it on the midpoint of the rectangular slab and trim the unwanted edges by analyzing the visible and invisible edges. These are our construction line, so it need not to be. It's going to be invisible, so invisible edges to be removed. And make is as a thick line, and but axis line should be thin line. Take a isometric scale for this. Scale 0.8164. This is the solution for problem number 3. And problem number 4, the following figure shows the top view of the cylinder which is centrally mounted on a frustum of pentagonal pyramid, 60 mm height. Draw the isometric projection of the combination of the solids. So for which, let us draw the orthographics of pentagon. The base of the frustum of pentagon pyramid is 50 mm sides. So draw a 50 mm pentagon. Here the diagram is given in the problem itself. So 50 mm 0 degree, 50 72 degree, 52 times 72 degree, 53 times 72 degree, 54 times 72 degree as an angle. I take this such a way that I'll rotate the pentagon in such a way that one of its edges is vertical. Get the dimension using distance between command. This is 50, 15.45. So like this, we are getting the distance dimension for all the corners, and it should be parallel. Choose horizontal or vertical dimension. Don't go for by 2 points method. So we have enclosed the pentagon in a box also. So let us take this edges as a 30-degree line. So the first dimension is 47.47. 47.55. 47.55 at an angle 30 degree. Next dimension is 29.39, 30 degree. Then 40.45, 150 degree. 40.45, 150 degree. 29.39 minus 150 degree. 47.55 minus 150 degree. 15.45 minus 30 degree. This is 15.45 minus 1 minus 30 degree. Then 50 we have minus 30 degree. Finally 15.45 minus 30 degree. So with this we can easily find the endpoint. Join the endpoint of this, we will get the pentagon. Now join the corner to opposite midpoint and corner to opposite midpoint. Corner to opposite midpoint. So intersection of these two perpendicular bisector is the center of the pentagon. So 34.41. So I take the from this midpoint 34.41 at an angle 30 degree. From there, we need to measure the height of the frustum of pentagon pyramid. The height of the frustum of pyramid is given 60, 90 degree. So the top face of the frustum of pentagon pyramid is 20 mm that we can see in the problem. We select the bottom pentagon, use move command, switch on copy, move from this endpoint and place it on this endpoint, and immediately go for scale and reduce the size. The scale factor is 20 mm side length we needed divided by 50 mm what we already having. So 20 divided by 50 is the scale factor, and you place it on this endpoint itself. Now join the corresponding corners using a thick line and continuous line. So above this we have cylinder. So let us take a line from this end point. The diameter of the cylinder is given 40 mm. So 20 mm, 90-degree, a vertical line we draw, thin line. Now from this, the total length of the cylinder is given in the diagram 100 millimeter. So 50 minus 30-degree and 50 at an angle 150-degree. So here comes the vertical circle of cylinder. So we need to draw a vertical ellipse. I draw separately from here. The diameter is 40, so 40 30-degree, then 40 90-degree, 40 minus 150, 40 minus 90. Join a line from this corner to this corner. Join this corner with the opposite midpoint, corner to opposite midpoint, and construct the ellipse. Ellipse by center point method, midpoint method. So intersection, this is the center. This is the intersection, the second arc, and the third arc. And finally, the last arc. Right. So now you move this ellipse with respect to the midpoint and place it on this end point. And switch off copy and place it on this end point too. Switch on copy. From this end point, you take another ellipse here. Draw a tangent line. Before that, I'll trim the unwanted edges. Just retain the ellipse. Join a tangent line for this ellipse. The remaining is going to be invisible. And this part of pentagon also is going to be invisible. So keeping control, select all this part of ellipse and make it thick, 0.5 mm. And this is the axis line. Choose axis type of line. You can trim the bottom portion also. So by trimming the unwanted edges, we can get the required solution. So this gives the solution for problem number 4. Thank you. Okay, later we need to take the scale for this. Select this entire diagram. Give scale factor 0.8164. This completes the example problem number 4.